Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name is Keith and I'm your host. Before we get started, class, how about the Pledge of Allegiance?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, for liberty and justice for all. Amen.
Okay, we're gonna just touch off. We've kind of figured out what we wanted. We got this up against our stop, located against our face. That's cutting a pretty good diameter right there. We're going to take a measurement. Okay, that's like 1 5/8. Okay, the inside of the tube is about 1/800, and we can make that 1 3/4, probably with no issues. Put a little bit more Alumatap in there. Makes the cutting go easier. All right, we're about 1/600 or so by the scale on our diameter right there. I'm gonna, from the first point of touching here, or knowing I'm touching, I'm gonna say right there, pretty close to, I'm gonna set 0 and I'm gonna gauge that. And I'm gonna go in 900 thousandths. So we can set a depth. Okay, there's 250. There's a 1/2 inch, 500. 600. Okay, 750. 8. And another 100. Right there is 900. Okay, 650. Okay, one little tiny porosity spot right there that just showed up in the last cut. Other than that, that material looks pretty darn good. Okay, let's put a little Alumatap in here. Spot's still in there, but it looks like it's coming out the other side, or it's filling in. Got another one right there, but overall that's looking pretty darn good. If we get it close and there's only a couple spots, we'll rotary burr, we'll fill in those spots, and then we'll go for the groove afterwards. So we can set this back in the machine at any time and relocate this bore. Thousandths under our finished bore size here before we put the O-ring groove in. We have got pretty good material for how nasty that thing was welding. We got a couple little porosity pockets right there, and we got a couple right there in a row that we're going to stop and we're going to fill in. There's probably one there in the back corner, but we're going to just leave that alone because it's going to be behind the O-ring surface. Alright, so we're going to touch up those spots and then get back in the machine. We set this back up, and I think we're close. So let's go ahead and give it a test. This is at the same diameter before we touched up the welds. And I'm going to crank it in by hand until I know it's okay. Pretty damn close. Okay, I'm feeding by hand now because we're coming up on the back, and I want to make sure that we're coming in and just cleaning down to that shoulder. Okay, I like that, and yeah, about 20 thousandths difference there, but we'll set the 0 on it now. Alright, let's blow that out and take a look at our repair spots. Okay, the spots in there look really good. And I'm going to go ahead We got about 50 thousandths left on that bore, but I want to creep up on it, and I want to have a nice finish. We did find a little bit of a dull tip on our bit there. We may resharpen it. We knocked a little piece, I think it was cutting some steel before, and we knocked a little piece off of there. I might take and hit it with a stone, but we want to get a cut all the way around, so there's another 10 thousandths per side. Yeah, that's actually looking a lot better in there. $30 thousandths left. I'm getting like 206, 205. I measured on the sleeve. It's anywhere from 185 to 205, you know, 2 inches, 5 thousandths, somewhere around in there. Let's go ahead and pull this bit out of here. And we'll see how that sleeve fits in there. And then we'll regroup on how we're going to put the O-ring groove in there. I like that. Okay, we may put a bit in here and go ahead and give this a little flat face, and then take our whizzy wheel and polish that, and maybe give a little bit of a radius going in, or a leading edge. You don't need much, just a break edge. This has got a leading edge on it here for the O-ring, to make the seal at the O-ring. All right, we just testing our process here of putting the O-ring groove in. This is a 226 O-ring. It's an 1/8 inch O-ring. Its actual width is about 138, and its inside is for a 2-inch diameter, and the outside is for a 2 1/4 inch diameter. And those sizes are slightly modified because of the thickness of the O-ring, and the compression is already figured into that. Our sleeve is 2 inch, and we're going to make that groove 2 1/4 inches on the depth, or on the diameter inside the groove. Okay, half of that, the depth. But I've measured my 2 1/4 inch, and I have my inside snap gauge ready. so that we can squeeze it and get the feel inside that groove. All right, now we're going to pick a dimension. What we have is a straight bottom, the 1/8 inch wide bit here. We're going to do the plunging, and then we're going to just move the table in and out to give it a kiss or clean on both sides there, so that the O-ring slips in freely in its free state. And then after it's compressed, then it will fill the entire O-ring groove and put the proper pressure against the sleeve. Alright, so we want to put this in about 400. 400 is about where we measured this, and I think that was the like center, and we kind of figured out that right about there looks good. Maybe just a little bit out. Okay, right in there. It's not a super critical in and out distance there. It was kind of ballparked in there. And I look at the other port, and I look at its O-ring, and I think we're going to start right there. Now, we have an auto facer that we're going to hold, and we're going to take a little bit as this goes around. We're not going. This is not going to be a race. We're not going to go real fast. All right, and we know that we're still out a little bit, and it takes a while for this thing to feed in there. So. Okay, pretty close to touching right there. Okay, on this head, we just engage this plunger. There we go. Okay, now when this ring rotates, it rotates the screw in the head and makes it face out. But I'm just going to be grabbing that slowly in increments, and we'll have a Lumitap here, and we'll be painting up the surface there so that we get freedom of cutting. And let's get some power. All right, let's check rotation. All right, it's going in the right rotation. I'm just going to give this a juicing. All right, now I just hold this ring right here. All right, starting to cut. Oh, grab my brush. Okay, that's a good sign. I think we're gonna stop and we're gonna take a look at our depth. It looks like we're about a 1/16 of an inch in there right now. Yeah, let's see if we can get a measurement in here. Okay, we're about 90 thousandths over 2, almost 100 thousandths. So we're about halfway on the depth. Here we go. Okay, we're going to check on the depth again. Two inches, 135. We're looking about when we flood it with our juice there, of what kind of finish we have in the bottom, because that's the one thing we need to have is a good finish in there. Two inches, 170. 2 inches, 205. Okay, so we got about 45 more thousandths come out of there. Only 22 and a half per side. I thought I had a funny reading there. Okay, about 220. Okay, I'm getting about 2 inches, 244 or so. Give or take a thou there. I think I'm going to let it spin around a couple times and maybe give it just a skosh more. Okay, now we got to play with the width. We know we're just a little bit narrow. Because that O-ring's not going to want to go into an exact 1/8 inch groove, is it? No, it's not going to want to. Okay, so we're going to have to feed, slowly we're going to have to feed in or out to gain some width to put that O-ring in that groove. Okay, I set up an indicator on the face of the table on the other side so that I can watch it. I'm going to feed the table in so that we're going to be cutting against that inside surface there. Our cutter width is 1/8 of an inch, right on the money. We need to make sure that this has clearance to drop into that groove, so it needs to be at least 140. This is 138, so we're shooting for 140, so we're going to feed the table in 15 thousandths. I'm going to put plenty of juice in there. Okay, it's looking glossy. We'll just keep the juice in there and we'll go a little bit at a time. That was like 4 thousandths. We're up to about 7. There's a total of 10. Okay, that's our 15 right there. All right, I'm gonna do, let's see if I can get it in here. Okay, I can push that in the groove right now. I'm happy with that. I'm gonna go ahead, and actually that O-ring feels good in the bore there as well. All right, we're going to shut down, we're going to clean it up, and we'll get a good look at it. Okay, let's put the O-ring in and see what it looks like. All right, and the sleeve. All right, I think we're satisfied with our bore, our O-ring. That feels good in there. Okay, we're gonna pop out the O-ring so we keep it, clean. We're gonna surface this outside slightly. Just take a nice face on here so we can roll in this leading edge right here, just so it's not sharp. We put our turning bit back in here because it has a nice flat face on the leading edge, and we stuck it out so that it's about the width of this thin section right here, and the rest of it we can blend in with a sander as needed. All right, we're gonna go ahead and fire up. And I think I changed directions already. Let's see. Okay, we have. All right, and little juice. All right, I think that's pretty close to making it flat all the way around, and that's all I really wanted to do. We'll blend a little bit of that edge in there. This is just meeting that edge right there. We'll hit this with the flapper wheel That'll roll over the leading edge here. We could have put a bit in there and we could chamfer that 45, but I think just running the paper is going to be the easiest thing. Alright, let's pull it out of the machine. Nice, smooths out that whole piece in there. There is some junk in there. Let's see if we can. Pretty good. I see little inclusion there, and I think pretty much we got one there and we got one on the edge right there. Other than that, got a pretty clean O-ring groove. Okay, we blew her out and we got a nice clean bore to take a look at now. I'm using this camera here so that you get a clearer shot and I don't have to move that one around. Alright, in the groove here you can see that there's an occlusion in the bottom of the O-ring groove there. But if you look, it's not on the outside, it's on the inside. And the bottom looks good where the O-ring is going to make contact in there. The rest of the groove, really sweet. Alright, for how filthy it was, silicone filled that back wall behind everything, had a coating in there and just really filthy, and a casting that just didn't like to be welded. We did pretty good. We had two major spots we came back and filled, and then we only ended up with that one little hole in the back corner down there at the bottom of the groove. Went ahead and mixed up a minute amount of Marine Tex, and we filled that little hole so that it's got something to support the ring. Other than that, it's going to be a beautiful piece, and when that cures, be able to lube up a ring, stick it in there, and drop that ring right in there. Alright. As we're working on that, we get another casting coming in. Here's a Cummins aftercooler. This is the O-ring surface that's got a issue here and here. Alright, but that's a project for another day. Until then, get her done.